Hello guys, welcome to Cisco with Amansoni, and this is our lecture number 14. So in this lecture number 14 we'll continue EIGRP where we left off. There are few advanced stuff that we'll discuss in EIGRP, so let's begin without any further delay. Okay guys, so let's start. You can use the chat box if you have any doubt. Okay, so the few things, like we have done basic EIGRP, and let's continue where we left off. Few things I want to show you: the EIGRP neighborship criteria, and I told you when EIGRP makes neighborship, hello packets are sent. So in those packets, what are the contents? So what I did, like we do not have GNS3, we are using packet tracer for our CCNA because it is very basic and very handy, easy to use. In GNS and also in real life, we can capture the hello packets. So what I did, I downloaded a EIGRP packet capture, meaning what, when two routers talk with EIGRP using the EIGRP protocol. So the packet capture is here using a separate software. So I'll just open it and let's take a look. This is how the EIGRP talks look like. Okay, so these are all the packets that are sent via the EIGRP. So as I told you, the EIGRP will first send the hello packet. Okay, and as I told you that unlike RIP, when EIGRP and OSPF send, they send using a special multicast address. A special multicast address is used. So in here, as you can see, the source is a unicast address and the destination is a multicast address, meaning what is starting with 224. In the subnetting, when I was telling you introduction to IP addressing, I told you the IP starting with 224 will be the multicast address. So for EIGRP, 224.0010 is reserved. Okay, so hello packets are sent on 224.0010, and the other router will immediately know that it is an EIGRP packet. So first thing, we'll send the hello packets, we'll make the neighborship, and then only we'll send what are known as the updates. Okay, so guys, these updates, as you can see, can be unicast like this because I have my neighbor IP address, and it can be multicast also sometimes. Okay, so don't get confused, but hello packets are always sent as a multicast. So let's see how this hello packet looks like. Okay, so now you have to be careful because this will show you a lot of information, all the details, nothing will be missed. So we are going to just keep track of all the basic information that EIGRP hello packet having. Okay, so let me just write the basic information for you. So we'll click here, and EIGRP, that EIGRP that is running now and that we use always on Cisco and on Cisco also, is version 2. Okay, because EIGRP was Cisco proprietary, but now it has made open, so other routers and switches can also use EIGRP. It is a hello packet. Okay, hello packet, update packet, all of them have some opcode with it. So the code for hello packet is 5. The checksum, okay, there will be some checksum to check whether it is error free or not. Some flags, sequence number, acknowledgement number, and some stuff. So let's take a look at the important parameters. Number 1, the AS number. I told you in hello packet there will be AS number will be sent. It will say that I belong to AS number. For example, it is saying I belong to AS number 100, and if the other side is to AS number 100, then only they will make neighborship. That's why they're telling each other their own AS number. So if my interface is part of EIGRP 100, I received a hello packet, and the other guy is saying I am in EIGRP 200, then they will never make neighborship. The parameters. What parameters? The K parameters. The K1, K2, K3 up till K6, and the hold timer also. Okay, the K values, they should match because I told you by default it will use only bandwidth and delay in the metric formula. We have discussed this. So for in that formula, if you have remembered, only K1 and K3 were made 1, rest were 0. Okay, so it is by default like this, and it must match. Okay, it must match on both sides. So these are also the contents of the hello packet and also the things that should match on both sides. Okay, so hold timer, yes, there is hold timer value also. So by default it is 15 seconds. Why? Because I am telling my neighbor, it's telling your neighbor that wait for this much time to for my hello. Okay, so if I miss a hello packet, like so let's say I'll send after every 5 seconds, which is the default value. So if I miss 2 hellos, then it will not break the neighborship. It will wait for this much amount of time. And if I have to change it, for example, if on my interface I'm changing 20, it will not take effect on my interface. It is I'm telling my neighbor. Then I'll tell my neighbor, hey, do not wait 15 seconds for me. Now wait 20 seconds for me or 30 seconds for me. So that's how it works. So if there any authentication, because in here we do not have any authentication. If we have some authentication, the password and authentication things will be in the hello packet also. If the password is not met, then they will never form the neighborship. Okay, so these are the basic stuff that is inside the EIGRP packet. Source unicast, destination will be multicast. And one other thing I want to show you, if you click here, the protocol number, as you can see, it is here showing 88. Okay, so they all have some like their numbers and all. Source is 001 and this is 240010. Okay, so these are the basic stuff. We do not need to go into MAC addresses and all stuff, so let's close this one. Okay, so these are the basic stuff. Now let's match. I have a table for you guys to just compare the neighborship criteria of EIGRP and OSPF. I know that we haven't started OSPF yet, but in OSPF also many things are similar. How you configure it is very similar, and it will start sending hello packets. Okay, OSPF hello packet will also have some parameters, and some parameter have to match, then only they will form the neighborship. Okay, so let's compare them one by one. These first three are you can see in grayish. Why they are in gray? Because they are not the routing protocol parameter. These are the basic necessities that should be fulfilled, meaning what the interface should be up and up, the state and the protocol should be up, and they have to be in the same subnet. I cannot have 192.168.1 on one side and on the other side let's say 21.1.0 network. No, then they will never form neighborship. There should not be any access list or any filtering mechanism. Okay, there are many filtering mechanisms using which you can filter out the routing protocol messages or updates or these stuff. So we do not need any ACL. Even if all the parameters are matched, everything is right, same subnet, but if we just put one line of ACL and apply it on the interface to deny the hello packets, they will never form neighborship. Okay, so first thing, as I told you, if the authentication is configured in EIGRP and OSPF, we both have authentication. If authentication is there, then it should be passed. Then other thing, they should be part of same autonomous system. Okay, it is same for, it is yes for EIGRP, which I have wrote down here. This is ASN. ASN means autonomous system number should match. Okay, so it should match. I'll write it like this. This value should match. Why? Because then they will not be considered out of your EIGRP boundary. But in OSPF we do not have this concept. That's why we have written no. Why? Because in OSPF there are no autonomous system numbers. There is some other thing that will come into place, that is known as areas. There is a concept of area. So there is no autonomous system, no AS number sent, so that's why it need not match in OSPF. Hello and hold timers must match. It is not there in EIGRP, so let's put here a note also that the hold timer is sent, but it need not match in EIGRP. It might not match. It's okay. Okay, it will be fine. But in OSPF, the both hello and hold timers must be matched. Okay, and as you can see that in the EIGRP hello packet, we are not even sending the hello timer, right? You saw only the whole timer, but in OSPF hello packet there will be hello timer and that timer also, and both need to match on both sides. But in EIGRP, if I have set to one side whole timer 15, I'm telling my neighbor wait 15 seconds for me, and the other guy is saying you wait 20 seconds for me, then the neighborship will not be affected. But in OSPF they should be matched. Okay, router ID must be matching or must be unique, it is written. In EIGRP it is said no. Why? Because in EIGRP we do not take advantage, we do not use router ID. First thing you might be wondering that what the hell is this router ID. Okay, so router ID is nothing, it is just like your identification number, like your unique ID, like your university roll number, like your employee ID. It's a unique number given to you to recognize you are in the network. Okay, it should be unique. But in EIGRP it is not needed. Okay, and do not worry about it, because we will talk about this in OSPF. When we'll study OSPF, each router will be having its own router ID. Now they should be in the same area. It is written NA. I skipped one K values. Okay, I'll come back to it. Must be in the same area. In EIGRP we do not have the concept of area. Okay, in OSPF we have area 1, area 2, area 3, area 0, like that. If a router is a part of area 2, then the other neighbor have to be part of area 2 as well. Okay, and yeah, K values. The K value that I've told you, I'll write it here. It should match also. The K value should match. So these are the must match parameters for EIGRP. Okay, interface should be up and up. There should be no ACL. Authentication we have written already here, I guess. Yeah, this should be matching. So these are the parameters that should match to form the neighborship. Otherwise it will never form the neighborship. K values we have in EIGRP only. That's why in OSPF you are seeing not, it is valid. We do not have any K values. Why? Because EIGRP uses bandwidth, load, delay, reliability. It can use, but by default it uses only bandwidth and delay. Why? Because in hello packet or in EIGRP, all the other values apart from K1 and K3 are 0, 0, 0, 0. So that's why everything else apart from bandwidth and delay nullifies. But in OSPF there is no such concept. We do not have any weird formula. We do not have K values. There is only one thing which OSPF uses, which is the interface bandwidth. That's it. EIGRP also uses interface bandwidth, but it uses delay also by default. And it have the option, if we manipulate the K values, you can go into EIGRP, you can set K1 to K5, all values 1. And then it will use bandwidth, load, delay, reliability. But why it is not done? As I've told you in previous class, that bandwidth and delay are the only constant values. The load and reliability will vary. That's why they are not used. So these are the basic stuff, the must-haves of EIGRP. So let's dig deep into few advanced stuff that we haven't completed. For that we need a basic topology. So what we are going to study today is the EIGRP variance. I told you EIGRP is the only routing protocol which keep track of the successor and the feasible successor. So in simple English, the best path will be in the routing table, and the second best, the backup path, will be in the topology table. Yes, it will be there, it will be stored in the topology table, but I will never ever use it. I will never ever use it in the routing table. So today our task is that we have to make it in the routing table somehow. Meaning what? If I have a backup, then I want the best path and the backup path both should be there in the routing table, and it should be load balancing should be happening. Why? Because if I'm using, see, I have one best path from here. We'll use fast Ethernet here. Okay, we'll use fast Ethernet here. So let's remove this serial thing. let's use fast Ethernet here. Okay, so we have fast Ethernet here, but on top we have Ethernet. Okay, but still we have one path, right? So why waste it? So that's why we want to utilize both the paths. Let's take a piece here. Okay, I think we ran out, did we? Yeah, so let's add some interface here. I told you it's quite easy. Just take the FE and add it here. And also, while we are at it, did we turn it on? Yeah. So let's also add Ethernet module here and here, because this one we want Ethernet. CE means Ethernet, but you have to turn it off. It shouldn't be green. So we have Ethernet here, and let's take Ethernet here. So actually we have done this task, if you have remembered, but it will be a good revision for you guys. So let's use Ethernet and Ethernet. Now this path below is the best, but we also want to use in the top. We want to have load balancing, otherwise it will be waste. Okay, it should be like just there lying around for months and months unless this path goes down. We do not want that. That is not how EIGRP use in organizations. We want this path and this path in the routing table also. If this path goes down, then only this will remain. Okay, so it's a good enough for us. So first thing first, let's write some IP address. Let's take 12.1.1.0 here. Why? Because let's call this guy R1, R2. Let's make this guy R3 and R4. So today I'll also tell you one EIGRP trick which will make things easy for you if you have only EIGRP running in your network. Okay, so this side will be dot 1, this side will be dot 2, dot 1. Let's take here. Okay, so we are today doing something different, some different IPs. Why? Because we want to make different things, so you won't get habitual to only one kind of IP subnetting scheme. So let's take dot 1 here and dot 2 here. Okay, so first thing first, that you need to go in there and you need to configure all the IP addresses first, then only EIGRP will come into picture. So let's get the easy part done first. The PC 192.168.1.10, 192.168.1.1 will be my default gateway. This will be this guy, fast Ethernet 6.0. So be careful. You can do this thing like keep the interfaces in front of you on right side on one side and the other side the CLI. First thing first, you have to change the name. So config t, host name R4, interface F60, IP address 192.168.1.1, interface F00, IP address 24.1.1.2, interface F10, IP address 34.1.1.2. So we have just assigned IP address and turn on the interfaces. Okay, so in the beginning it is better if after configuring the IP addresses you will check them, that we have the 24.1.1.2, 34.1.1.2 and what we all need. Okay, and just match with the topology. So dot 2, dot 2, dot 1 here. Let's move on to R2. Interface, that's better if we change the name first. Interface F00, IP address, so we wanted here 24.1.1.2 and interfaced Ethernet 6.0. Okay, be careful, we are not using fast Ethernet here. 12.1.1.2, done. So let's move on to R1. interface Ethernet 60. It is not necessary that you should take like Ethernet 6060. If you add multiple interfaces, the numbers can be different. 12111. Other interface is 13111. So let's move on to R3. Hostname R3 it is. Interface F10 or 00. On one side we have 13112. On other side we have I think it was 34 right here. 34111. And do not forget to no-shut the interface. And once you are done, all the links in the topology should be green, because on router the interfaces are shut down, interfaces are down by default. So now we have to configure EIGRP. So there's a trick to it that I want to teach you, a new one. Like for example, you do usually like this, right? You do router EIGRP 100, then you do no auto summary. Why? Because I want the subnet mask to be carried. Then you do network and you write down the network. Like for example, if we are sitting on R1, you will do it like this, 1200, or you can do like this. It will be the same thing, okay? Because router is a classless. The router doesn't care. It will just look on the first block. If it is 12, it will turn on EIGRP. So you can do 1211 or you can do 1200. It is the same thing. For the other side, you can do network 1300. If first block is 13, then turn on EIGRP. That's it. You are done. So that way we were doing till now, R1, R2, R3 for every router, the network command, and afterwards it will be something else. But there's a trick to it, that if you want to turn on EIGRP on all the interface, of your router, so you can just write network 0000. That's it. Because if you have remembered, 0000 means anything. So if you want to turn on EIGRP on all the interface, whatever it is running, just do this command. So how to turn on EIGRP on all the interfaces of the router? But you have to be careful with it. Why? Because if you have some interface where you do not want EIGRP, or you want OSPF, like I have two interface EIGRP, two interface OSPF, so you can never ever do this command. But in here it's not the case. On every router, on all the interfaces present, we have EIGRP running, and everything is in EIGRP 100. So we can write here that in here the EIGRP AS is 100. So what we'll do, we can just copy the config. Okay, let me remove this exclamation, otherwise it will consider this as a comment. So let me copy it. So I have to just paste it. That's it. And how to check if EIGRP is running on what interface? Show IP EIGRP interface brief you can do. That was for OSPF. Show IP EIGRP interface. So I have two interfaces, and on that immediately EIGRP started running. Why? Because I have only two working interface. If in future I turn on any other interface, two other interface that I have in here, these interface, if I turn on, immediately EIGRP will start running. Why? Because we have done 0000 command in network. So that's why, yeah, it is a double-edged sword. You have to be very careful, but it is very handy in the topologies if where you have EIGRP running on all the interfaces. So R2 done. Let's go to R4. Oh, see, you have to be first inside the config mode. So let's move on to R3. Oh, you are already in the config. Okay, so now what should be there? If you are sitting here, you should be able to reach this guy. So today is like all the little bit advanced stuff, and also I'll show you some other stuff. They have hidden it. Okay. So okay, I want to see if I have some EIGRP neighbors. I have two EIGRP neighbors. One is 12.1.1.2, another one is 13.1.1.2. But I know that only the bottom one is best, because path from here is the best. Why? It is fast Ethernet. How we will check? Show IP route. Simply in show IP route, for the destination 192.168.1.0, you can see there is only one route, which is via 13.1.1.2, which is via 13.1.1.2, and 13.1.1.2 is here. Okay, but what about the 12.1.1.2 path? Is it like non-existent or no? I told you it's not like that in EIGRP. If you are running RIP or OSPF, it might be something else, but it will be hidden away by EIGRP in the topology table. So if I do that, okay, for some reason it is not coming here. So let's take a look that why this little path is not here. Let's check here. R2 show IP EIGRP. I think we might have missed some neighborship. See, in here I should be having two neighbors, but I have only one neighbor. So how to troubleshoot? If anytime you ever face any issue in EIGRP, first thing command that you will do, whether EIGRP is running on all my interfaces or not. It is running on all the interface. Then you go on the other side and you do the same thing. Show IP EIGRP interfaces. So I have EIGRP running on F00. So then let's check the IP. Show IP interface brief. I have 24.1.1.2 here. So let's check here. What do we have? Show IP interface brief. See, I have 24. So by mistake, what we have done, we have made 24.1.1.2 here, 24.1.1.2 here. Okay, so that's how you will troubleshoot EIGRP. It's very simple. How? First you will check whether I have EIGRP running or not, whether I have neighbors or not. Then you check whether I have on the interfaces or not. Then you will check the IP address, and even if you are not able to get the solution from there, then you will do show running config, and then you will go inside the interface config and then check. Might be you have give correct IP or forgot no shirt, or you have given some other weird command. So let's just change this IP interface F00 IP address 24.1.1.1, and immediately my neighborship of the EIGRP is so fast. Okay, in RIP you should have wait around 15-20 seconds at least. So if you go to R1 and you refresh the topology table, instead of one route, now you will see two routes. Why? Because now this is the proper working EIGRP scenario. We have two routes, but only one of them is the successor. Which one? Which is having the FD value of 33280. What is FD? Nothing but the total distance, feasible distance towards the destination. It is 13.1.1.2, best path. So how I will make this guy the 12.1.1.2 in the routing table? Because by default it will never come in the routing table. So for that there is this special method to do that, which is known as variance. So let me show you what is variance. I have written some notes for that what is variance. First of all, what is your task? Okay, our aim is that the successor and feasible successor to send the data, both should be in the routing table. Both should be in the routing table, which are not there by default. Okay, so I've written that here also. Okay, so and we know the cost from the best and the second best are different, right? Why? Because you can see in here, right, that the costs are different. Let me close the others. See the cost or the distance, you can see the distance are different. This is 33280 and this is much higher. That's why this guy is not the successor, right? Okay, so how we'll do that? So first thing, what is variance? We will use variance so that the backup route from the topology table will be copied to the routing table. Okay, and this is there is a special terminology for that, which is called unequal cost load balancing. Okay, this is known as unequal cost load balancing if we somehow manage to put the backup route in the routing table also. Why? Because both the cost or the distance for both of them are different. If I would have used fast Ethernet here, then I would have simply had two routes automatically in the routing table without even to do anything. Why? Because then for both of them the distance would have been 33280, and that would have, you have called it equal cost load balancing. So what is our aim for today? Our aim is unequal cost load balancing. How to do that in EIGRP? So first thing we should be knowing that what is variance. Okay, so variance is nothing special. It is just a integer number. It is just a number. So there is a formula, there is a condition which is always checked. If that condition is true, then the backup route will be copied. If this condition, there is one condition I'll tell you, if that mathematical condition is true, then the backup will be copied to the routing table. If it is false, it will not be copied. And as you can see, by default it is not being copied, right? Why? Because by default the condition is always false. So what is the condition? The condition is pretty straightforward. If you see it here, take the variance, whatever it is. I told you it is an integer number. So take that integer number, multiply with the feasible distance of the successor, the best cost, the best total distance. Okay, take that, and this value should be greater than the FD value. Okay, this should be the greater than the FD value of the backup. So by default this value, this condition is always false. What I'm saying, take my best distance, it is best, right? It is best, and multiply it with variance, and it should be greater than the distance, total distance of the backup. It is never like that. It is always less. It is always less. That's why it is the best path. Okay, so if you're getting confused, it's pretty simple. Just remember it mathematically and check it in here. It says, because by default variance is 1, and if variance is 1, so I'll put 1 here, and it is simply saying that the feasible distance of the successor should be greater than the feasible distance of backup. It can never happen by default. Why? Look it here. This is the best path. He's saying this FD value should be greater than the FD value of the feasible successor, which can never happen. But we can make it happen by changing the value of variance. Okay, so if we multiply this by 2, what will happen? Will this value be more than that? Let's try. Okay, so that's how you calculate the variance value. So let's take this value. If some of you are good in maths, you might have easily have calculated, and you might even say just divide this number by this, then you will get that. Okay, but let's keep it simple. Let's multiply it by 2. 6. So it's not, see, it is not more than that. So there is one simple trick, guys. Okay, just take this FD value 286,720 and divide by 33280, and you will get a number 8.6. So it means we have to multiply this number by 9. Simple as that. It is simple math. Okay, so 33280, if we multiply this by 9, we will get a value which is more than this. Then the condition will become true. So again, let me just revise it for you. What is the condition? Condition says take the variance, multiply it with the feasible distance of the successor, the best one, and this value should be more than the feasible distance of the backup, which is by default always false. Why? Because variance is 1, and if 1, it means it is saying this value should be more than this. False. That's why this backup will always be lonely and staying in the topology table, will not never end up in the routing table. But if we somehow make the variance 9, then we know this condition will immediately become true, and if it become true, then we have to copy the backup route to the routing table. And how to change the variance? The command is super simple, you can even guess it. Just go to router EIGRP 100 and variance, and then give the variance value. And if you want to see like what is the current variance value, let me show you. Show IP protocols. You will see variance is 1. EIGRP metric variance is 1, and the K value is also by default. These are the default stuff of EIGRP. But if we make variance 2, 3, 4, 5, 6, nothing will happen unless we make it 9. If we make it 9, immediately the condition becomes true. What condition? This value multiplied by variance should be more than this. So if we multiply by 9, the value which comes will be more than this value, and this route will go immediately, the 12112 route will immediately go in the routing table. So in here right now it is not there, right? So let's change the value of variance. Variance 9. That's it. And yeah, it will reset. Obviously it will reset your EIGRP neighborship. And do show IP route. Immediately you will see unequal cost load balancing happening. It has copied the route and it has pasted it here. In simple English, it will be now used, both of the routes will be used to send the data now. Load balancing will start happening. So this is your variance. Okay, it is quite easy, but all you had to do is understand this condition. Okay guys, so this was all about your variance and EIGRP neighborship criteria, what is inside the Hello. So few things, like I told you, I promised you guys that I'll show you DHCP relay agent, but we have got chance to do that. So let's finish that today. What DHCP relay agent? So it's quite funny and it's quite interactive. Okay, why? Because in DHCP it is super easy to do. You just have to give IP, DHCP pool, network, and that's it. But what if I have many networks? Then I cannot do DHCP everywhere, right? It is absurd. So what I will do, let's imagine that R1 is my centralized DHCP server, and I want this guy to not take the static IP. I wanted him to take the DHCP IP. Same 192.168.1 from this network. If I click on DHCP, it will not take it. It will take 169.254, which is APIPA, automatic private IP addressing, which is PC assigning it to itself. Why? Because there is no DHCP. So let's first do that. I'll make the DHCP here R4, just so that I can jog your memory. Then I will remove the config from here and take it and put it on R1. So it is, I'll just put old things, IP, DHCP, pool, P1, whatever name, okay, or you can put my pool, whatever you want to put here. I put my underscore pool. Then you will say network, and I want to assign IP addresses from this network. Pretty simple. I want you to give the default gateway as this IP. If you want this guy to access the internet, I'll say DNS server should be 8888. Okay, so this is my, I think I might have enabled the DHCP here, because that's why we got this message. It has already taken IP from DHCP. So what we have done, this is my DHCP config. Simple. Okay, we have done that before also. So we have put it here. This is my nothing but my DHCP config, and this guy have become the server. Which one? This R4 it become DHCP server. If I click here, if I click on command prompt, oh sorry, IP config, and see no IP. If I click here, it will request, and immediately I'll get my IP from that pool, my default gateway, and even my DNS server. Now what I will do, I will take it, I will remove I'll delete the pool, and I'll put all this config on R1. And if funny thing will happen, the DHCP will be broken. There will be no DHCP working. Why? I'll explain you why it is not working. No IP DHCP pool, my pool. Okay, be careful with the name, otherwise you will might delete some other pool. Okay, so first check whether it is not working, because there is no DHCP right now. It will fail. See, DHCP failed. So let's put this config here on R1. Simple, same exact config. I haven't made a single change. But if I connect a PC here and put 192.168.1 IP here to its interface, immediately it will get IP. But what about the far away users? What about them? Will they able to get the IP? Let's check. DHCP failed. Why? Because I explained you in the DHCP things that there are 4 packets. The DORA process is happening: discover, offer, request, acknowledgement. And I told you that the few packets, that for example the very first packet itself is a broadcast. Okay, and the broadcast packet will be traveling here. Sorry, I just wanted to locate the marker. Yeah, it will send here the discover packet. Is a broadcast, and router, my friends, router will never ever forward a broadcast. It will break a broadcast. Okay, it will break the broadcast. So that's why the broadcast will never ever go anywhere. It will be just here and that's it. Why? Because it is a broadcast. So, but we have to make this broadcast somehow reach here. Then this guy will send the offer. Then this guy will receive the offer and forward it to the guy. Then he will send the request, and this guy should be able to forward the request. Then he will send the acknowledgement, and this guy should be able to forward the acknowledgement, and then this guy will get the IP and use it. So if you can think logically, R4 is what? R4 is nothing but a agent, right? We have to make R4 what is known as a DHCP agent, or the correct keyword it is, or correct term is DHCP relay agent. Why? Because his job is take the information and relay it to the DHCP server, and take the information back and relay it to the users. So we have to make this guy DHCP relay agent. Okay, so how you will make this relay agent? You will go to the router R4 and you will tell him that where is your DHCP server, and that's it. If you tell him that dude, you are not the DHCP server, this guy is your DHCP server, and that's it. You have made this guy a DHCP relay agent. Now what he will now, but the question is still here, that if I make this guy a relay agent, will he receive my discover and will he forward it? No, it will convert and forward it actually. Why? Because it is a broadcast, and I can never forward a broadcast, right? If I imagine if I forward a broadcast outside my network, it will be crazy. It will be, because broadcast, then it will be everywhere, right? So I will receive the broadcast, convert it into a unicast. Yes, it will be a discover. I'll convert it in a unicast by using my source interface IP. Okay, and where you will configure this DHCP relay agent on the incoming interface, where the DHCP incoming packets will come, where the DHCP incoming packets will come from the users, okay, from the users. So in our topology it is fast Ethernet 6.0. okay, so how to configure DHCP relay agent on R4? Okay, I'll tell you the command. Config T interface F60, and this is the command. IP helper address and space the IP address of your DHCP server. Now guys, don't get confused. If I ask you who is your DHCP server, you will say R1, but what is the IP here? On R1 we have 12.1.1 and we also have 13.1.1, right? So you can use whatever IP, okay, it is up to you, because both IP reside on your R1. You can use 12.1.1, if you want you can use 13.1.1 also. That's it. Now this source IP address will be used and I will send it as a sorry, not this 12.1.1, this will be a destination actually, okay, this will be the destination. Source will be the IP address of my this F60 interface, okay. I'll receive the broadcast, because in broadcast this destination IP is 255.255.255.255. I'll remove it and I'll paste it with the helper address, with the real DHCP server IP. So that's how you do that. Go to the interface, then say IP helper address and the IP address of the DHCP server. That's it. This will be the destination IP instead of all 255s. So let's see if it works. And there's one additional requirement to a DHCP relay agent, that you should be having some sort of connectivity, okay. If you cannot even reach, if imagine if R4 cannot reach 12.1.1, then will this whole thing, will it ever work? No, it have to reach 12.1.1. now how you make that reachability, it's up to you. You can use static routing, you can use EIGRP, OSPF, RIP, whatever you like. In our case we are using EIGRP. So let's see if this whole thing works or not. So let's click on static, click on DHCP, and it was successful, okay. And as you can see in here, we do not have any EIGRP, any DHCP. Show IP DHCP pool, there is no pool here. The pool is sitting far away on R1. So this way I can have one centralized pool and not any pool, sorry, server. I can create many pool here. I can put a PC here, I can put one PC, one network here, and all of them, this guy will be 192.168.2.0. let's take this guy will be of 192.168.3.0. so all these three networks users will get IP from this centralized server. So this is your homework, this is your task that you have to do. What you have to do, EIGRP with variance and all these network, like you have to create 3 networks instead of 1, and all these 3 should get IP from this guy right here. And in here obviously you'll create 3 DHCP pools, one for this network, one for this network, and one for this network, okay. So this is your task. I'll just take a picture of it and save it in the file, okay. So I'll share it with you, okay. So just use packet tracer and perform it, the variance task and the DHCP helper agent or DHCP relay agent, you can say it also. Okay guys, so do try the whole thing, okay. And also like follow this whole series. If you have any doubt, if you want to have some revision sessions with me, or if you want me to assist you via TeamViewer, I'm ready to do that, okay. Just ping me in the, just put in the comments and I'll glad to assist you guys. All these links I'll put in the I'll upload in my Google Drive, and the link I'll put in the description, okay. And also guys, like a small request that do not forget to subscribe and like and share your feedback with me, okay. And as always, keep rocking. I'll see you in the next lecture. Goodbye.